Welcome, my dear friends. Today I have brought a topic of electron emission, and this electron emission is from the chapter of dual nature of radiation and matter. The topic is completely given in physics of CBSE 12th standard. First of all, we all know that our 12th standard students, they are preparing for their board examinations, and even they have already received their admit card. On 20th of February, the examination will start, and the first paper itself is physics. So just I want to tell you all that the second part, part 2, mostly it will be having questions. Of course, numerical questions are also there, but it will be having more theoretical questions also. It doesn't mean that part 1, which includes electrostatics, electric potential and capacitance, current electricity, magnetism, magnetism and matter. So all those chapters will not be having theoretical questions. Of course, theoretical questions also will be there, and numerical questions also will be there. But the part 2, it is of different nature, where we will be talking more about light. It will be consisting of wave optics also, ray optics also. So the topic which I have brought here, that is electron emission, how the electron will be emitted from a material which are photosensitive, right? Once the electron will be emitted, then only we can get the current. So we all know about photovoltaic system, right? All solar panels are working on these electron emissions. They are these are means in solar panels, photovoltaic panels are there. It means falling of light. If the light will fall on it, it will generate potential difference. It's only because of the electron emission. So once again, I want to inform you all that exactly the page I have taken from NCERT e-textbook, which is not created by me. Total credit goes to NCERT e-textbook, and the information which I am giving to all, it will be useful not only in your board examination, but also for your NEET examinations, G examinations, CUET examinations. Of course, everybody would have filled the form now. All forms have come out. Right. So once again, I am telling that these contents I have not taken, or it is not created by my own. Directly I have taken from the book, and we will be reading these lines so that we can understand in a nice manner, right? So this content, pictures, everything, the total credit goes to NCERT e-textbook and the original creator. Right, I have brought it only for academic purpose so that we can have a discussion. So electron emission, the topic is electron emission. From the word itself, we can come to know that something is emitted from a material, right? So how that electron, we know that all matter consists of atoms. An atom will be consisting of electrons, protons, neutrons. We are focusing on electron emission. So electron emission will be taking place only when some extra energy will be provided to the material, right? Extra energy will be provided to the material, and when the energy will increase, that electron will jump from its cell, fixed cell, and then it can get emitted. So let us see the lines what it says. that we know that metals have free electrons. Of course, metals have free electrons. Metals are good conductor of electricity, and metals have abundance of free electrons. Yes, electrons are negatively charged particles, and these electrons are only responsible for their electrical conductivity. So, the free electrons cannot normally escape out of the metal surface. See, once the surface is neutral, it means the electrons will be revolving in its fixed orbits. It will not be coming out from the metal surface automatically. Okay? So, if an electron attempts to come out of the metal surface acquires a positive charge. Now, suppose the electron has come out from the metal. So, what will happen? The electron deficiency will take place, due to which the metal surface will be acquiring a positive charge. Yes, it will be a positive charge, and what this positive charge will do, it will be pulling back the electron to the metal. Okay, so it will not allow simply for the electron to move out. Okay, so the free electron is held inside the metal surface by the attractive forces of the positive ion and negative ions. Okay, right. Next sentence says, consequently, the electron can come out of the metal surface only if it has got sufficient energy. When more energy is supplied to the metal surface, and the electron will be acquiring that energy, extra energy, which will be overcoming the attractive pull by the metal surface, then that electron can come out. It means certainly the electron needs some minimum amount of energy, and then only further, when that minimum amount of energy will be reached, or more than that minimum amount of energy, the electron will be leaving the surface of the metal. So a certain minimum amount of energy is required to be given to an electron to pull it out from the surface of the metal. And this minimum energy required by an electron to escape from the metal surface is called the work function of the metal. So here comes the definition of work function, right? So work function is the minimum energy. The word says work function, right? But actually it is minimum energy required by an electron to escape from the metal surface. And it is denoted by phi 0. Okay, phi 0, and measured in electron volt. Electron volt is the unit of energy. So 1 electron volt is the energy gained by an electron. What is 1 electron volt? How can we define? It's the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. When it has been accelerated by a potential difference of 1 volt, so that 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. We all know that the charge on an electron is 1.6 into 10 to the power of minus 19 coulomb, and that charge value only it is there. So if we want to convert electron volt to joule, we need to multiply with 1.6 into 10 to the power of minus 19. If suppose the energy is in joule and we want to convert it into electron volt, in that case we have to divide that given energy in joule, and we have to divide it by 1.602 into 10 to the power of minus 19. Okay. So this unit of energy is commonly used in atomic and nuclear physics. In atomic and nuclear physics, electron volt unit is used. Means the energy unit is electron volt, and the work function, that is phi 0, it is depending on the properties of metal and the nature of its surface. It depends on the properties of metal and the nature of its surface, the work function. So from this particular slide, I am expecting, it is my expectation that the students would have understood that electrons will not be simply leaving the metal surface. Even if an electron will try to escape from the metal surface will acquire positive charge, and due to that positive charge, the electron which is trying to escape will be pulled back to the metal surface. And that's why the metal surface maintains its neutrality. Always it will be a neutral surface. Now the question is that how an electron can be made to escape from the metal surface? When it will absorb extra energy. When the electron will be absorbing extra energy, it may be of any form. How that extra energy will come, that we will see. But that extra energy, if it is absorbing and there is a certain minimum amount of energy, we can say that which is compulsorily required to make the electron to come out from the surface, to get pulled out from the surface of the metal. And this minimum energy required by an electron to escape from the metal surface is called the work function of the metal. And it is denoted by phi 0, and the energy is measured in electron volt. This electron volt energy unit is used in atomic physics and nuclear physics. What is the value of 1 electron volt? That also we have understood, that is 1.6 into 10 power of minus 19 joule. And by utilizing this particular relation between electron volt and joule, we can convert the energy given in joule to electron volt, or the energy given in electron volt to joule. Okay? And work function is depending on the properties of the metal and the nature of its surface. To the students, once again I want to tell you that there may be a question that how to define electron volt, 1 electron volt. So we must be able to define it as the energy gained by an electron. Okay, 1 electron volt is the energy gained by an electron when it has been accelerated by a potential of 1 volt, potential difference of 1 volt. Next slide. Now the question is, where from that extra energy will be coming, that minimum energy which we need, work function. Okay, so the minimum energy required for the electron emission from the metal surface can be supplied to those free electrons by these 3 processes. The first process is thermionic emission. Therm means heat, ionic emission. So due to the application of heat, ions will be created. When ions will be created? When the free electron will be coming out from the surface, thereby the metal surface will acquire positive charge. Okay? So by suitably heating, sufficient thermal energy can be imparted. Okay? Sufficient thermal energy can be imparted to the free electrons to enable them to come out of the metal. So this is by supplying heat, by giving heat, external heat. Then second is field emission. Now by applying a very strong electric field of the order of 10 to the power of 8 volt per meter, yes, of the order of 10 to the power of 8 volt per meter, this is called field emission. By applying a very strong field, electrical field, that is 10 to the power of 8 volt per meter to a metal, electrons can be pulled out of the metal, as we see in a spark plug. Yes, spark plugs are there in the vehicle, mainly petrol vehicles are there. The vehicles which are running using petrol, 2-wheeler, 4-wheeler, these vehicles are having a spark plug. Okay, so in a spark plug, a strong spark is created. Spark is supplying heat. Okay, so that spark is created only when the electrons are pulled out of the metal by applying a very strong electrical field, and that is of the order of 10 power of 8 volt per meter. Third way of making the electrons to escape means supplying energy, that is photoelectric emission. Photoelectric emission. So when light of suitable frequency, when light, okay, so this is called photoelectric emission. Photo means photon. It has come from the word photons, and photons are actually light energy. Photons are light energy. Okay, so when light of suitable frequency, yes, all lights will not be generating this emission process or creating this emission process. When light of suitable frequency is illuminating a metal surface or falling on a metal surface, electrons are emitted from the metal surface. So these photo or light generated electrons are called photoelectrons. Okay, these light generated electrons are called photoelectrons. So we discussed in this particular slide that how that minimum energy can be supplied to the metal surface for making it to escape from the metal, and that is by using heat or by supplying additional heat, suitably heating at particular temperature, suitably heating, sufficient thermal energy can be imparted. That process is called thermionic emission. Then field emission by applying a very strong electric field of the order of 10 power of 8 volt per meter. And third is photoelectric emission by illuminating the surface with a light of suitable frequency. The light of suitable frequency. And this light generated electrons, photo generated electrons, are called photoelectrons. We have come to an end of this particular video. We discussed only this particular topic. Yes, I wanted to discuss only on electron emission today. For next topic, photoelectric effect, we will be discussing in next video. If you have liked, kindly share with your friends also, those who are appearing in the examinations now. Let us take this particular initiative to make everybody understand to others also. Thank you very much.